Hello everyone, welcome to another video, and this time we will use a slightly different sample file. Basically all elements are in this sample file Revit link. So if we hide that for the moment, in our model we will just have levels and two lighting fixtures. So I will go undo, I will lock again my selection. So we need basically over here just to see ceilings and lighting fixtures. Okay, so we have one lighting fixture on the 8th floor, I think. Yeah, it's on 8th floor and on the 15th floor. No, yeah, it is 15th floor. Okay, so what was my idea? Now I will turn off this 3D view. So from one side I have some lighting fixtures, and let's consider that in this case we have only one room. So in space schedule I did filter only this room number 8. It has almost 240 square meters, and right now estimated illumination for this light and for this room is 5 lux. So now I did try to create something else, but like a break from that job I did create some I think it is good script. We can learn a lot from this script. So this will be the part of the practical Dynamo course, so it's not finished script, but maybe you can learn from this script some materials, or this can be a new idea for you to create your own scripts. So what we can do over here in this input zone, we can of course select lighting fixture. So we'll select this lighting fixture. Now what is important for lighting fixtures, because they are the hosted element, we need also to select face. So I will select this top face. And now I will say what is the requirement for this room. The script must create some numbers of the lights in the X and Y direction, and the result must be around this value, because each light can contribute either 5 lux or 20 lux or 50. We can play with the power or wattage. So you cannot have rounded values in a way that you will say I want to have 400 lux and the script will create just that amount. I mean, you can do it if you iterate this power, but you will have at the end, let's say, power of maybe, I don't know, 46.2 watts, and then you cannot buy this kind of the lighting features on the market. So you will have as a result over here some value which is close to what you did require. So at first we can try to go with 200 lux, and over here we can also select what we want to have as a X distance. So this ceiling is 600 by 600. So if we say that we want to have 1200 millimeters distance, that will mean that between this and the next light feature we will have 1.2 meters. We can of course change that. I did configure this number slider in a way that the increment is 600 millimeters because of the ceiling. So maybe as a start we can go with 1.8 meters, and it's a play. So in a couple of iterations I think we can find a proper solution. So the script automatically created some number of the lighting fixtures. The result is 217 lux. We did require 200. That is okay. What is also important, so over here we have lighting fixtures, then we have 600, 1.2 meters, and over here it's 1.8. So the script did respect this X distance over here. You can ask, okay, but why didn't we log also this distance? Well, because the script will automatically calculate how many of those light fixtures you need, and if you say which distance you want to have in the X direction, basically then you don't need to, you can, but I think you don't need to log also this Y direction, because it will be a calculated value. The script will calculate how many rows you will need to have in order to have some value of the illumination which is close to what you require. So okay, over here we have some number of lights. Over here we have, let's say, the shaft for installations, and we will have elevator. So either we will move a little bit those elements, or we can just delete those elements now. Yeah, and now because those elements didn't belong, I will undo that. So those elements didn't belong actually to the room. Can I select this space? Let's. So those elements actually didn't belong to our space, so that is why when we delete them, it will not change our estimated illumination. On the other hand, if we took those elements and place it somewhere in the room, then we will increase our illumination. So I can freely just delete those elements. Okay. Now we can say that we want to have, for example, let's say that we want to have 300 looks to be our requirement. Again, we can run the script and we will see what is the results. Now this is interesting. So now the script cannot completely follow all our guidelines. So I did say what I want to have as X direction. The calculated value for the Y is something, and what is very important, I did put in the script. For example, if I did place the lighting features over here, and the script will calculate what is the length over here, and it will try to have similar length over here. It's same with the Y direction. So if I did leave over here 1.5 meter, it knows that it cannot go all the way over here to 1.5 meters. So that is why we have over here some clear zone, and because we did require 300 looks, now we cannot follow entirely that increment of 600. So now we have a lot of lighting fixtures. They are not perfectly aligned, but at the end we did have 325 looks. Again, over here, I think if I delete those elements, the number will stay the same. Now when we have situation like this, now we can say, okay, so I did try to create lighting fixtures, but I didn't like the grid and the number of rows which I have over here. So now you can say, okay, but then I will increase the power of the light. So instead of 30 watts, and we can check it over here, so current lighting fixtures have 30 watts of power. So now we will say to our input, okay, let's go with 50 watts. We will still require 300 looks, and now we will play the script. So again, now we have relatively even distribution of the lighting fixtures. Over here we have 361. It is more than we did require, and now also we can check if that power is changed. Yes, it is. So now our lights have 50 watts. That is okay. Also, we can play in this way. We can say in the X direction we want to have 1.2 meters. So we will maybe reduce those numbers of rows. Yes, now we have just 3 rows over here, and we did succeed to have more illumination than what we required. So that is also good. But over here we did increase the power, and we also reduce X length between the devices. You can go also this way. So if we increase X distance, can we now satisfy all our conditions? Yes, we can. So it is okay for illumination. I don't know if we delete this one. Yeah, we did slightly decrease illumination, but still we are above required illumination. We have pretty even distribution of lighting fixtures. And now I will just show you similar thing, but on this level, because it have a different floor. So again, let's so we need to select this lighting fixture, and we want to select this top face. At the beginning, again, let's go with 30 watts. Let's require 300 lux, that is okay. And let's again go maybe with 1.8, that is it. Again, the distribution between the rows, it is not aligned with the ceiling. And over here I must change our filter. So now we are looking at the space 15. So we did satisfy this condition, but it is not good distribution of the elements. Again, we'll go undo. Let's go with 50 watts, and let's go with 100 watts, and let's go with 450 for the lux. And let's now see if we can satisfy all those conditions. Yes, we can, and we have 600, so we can maybe decrease this to be 80 watts. Again, it is good. With 80 watts we can maybe go with 2.4 meters per X distribution. I would delete those elements. Yeah, this is looking good. So this script, I mean, it's not finished script. I cannot guarantee what would happen if you have some corridor where you have boundaries with maybe, I don't know, 10 curves. But for this kind of room, when you have basically the rectangle, even when that rectangle has some custom angle, this script will work. And now I will show you Dynamo script. This is the entire script. I will walk you through, but before that, again, let's just see what the script need to do, like some algorithm. So the first thing is when you have some lighting features inside the room, this information over here is pure gold. So now you know when you insert one lighting features, how many looks that lighting features will generate. And from the other hand, you have what is required, and you can simply calculate how many of those lighting features you will need to have. That is the one thing. The second thing is you will need to find from the space geometry what is the maximal length of, let's say in this case, that is X direction. And also you will need to find maximum length of this, let's say, Y direction. Then it is very important to know where the user did place these lighting features inside the room. You will not have the same results if you put these lighting features over here. Then the script will try to generate, and we can try that. So the script in that case will try to generate oh yeah, okay, we will run the script through Dynamo. So now because we did place lighting features over here, the script did try to have what is required in that small space. So the script is really trying to do the symmetry. So if you did separate your lighting features for some amount from the X, it will try to go in the opposite direction for the same amount, and it is same for the Y direction. So it is very important to pick properly this light feature. And then when the script determine this length over here, the total length in both directions, then it will also read what the user choose to have for the X distance as a value. Then when you divide what is left of the land and what is user required, Dynamo will know how many of those lighting features can generate, and then it will again divide what is required and what we have over here right now, and then it will just see how many of rows we will need to have in order to be above what is required for illumination. So it is not simple algorithm, but if you know some better way, you can let me know. So let's see over here what we have. We will choose lighting feature, and this is of course our input, and then we will for that element read in which space we have that lighting feature. Now this is also very important. Actually, when you run this script, it will run twice. You will have over here two things to undo. Why? Because Dynamo will read what power, what wattage we have for some light, and then if you want to change that, for example, over here we have, I think, yeah, 80 watts. If we have 30 watts, 30 watts will generate this amount of lux, and basically our entire algorithm is based on this value at the beginning. So if the user chooses to go with the same power, that is okay. But if the user in the input zone change what should be the power for the lighting features, then basically we will need to set that, to read that, and to get to know this updated value. So if you change in your input over here to have, I don't know, those 80 watts, we will not have those 6 lux anymore, we will have 16. So that is very important thing for our algorithm to calculate all other different values. So we will run the script once to set, and then we will again read this value if the user changed. And basically this part over here we did now explain. So transaction end and transaction start will stop the script and run the script again. So over here what we have, what is required, and that is also an input. Over here we now can see how many of those lighting features we need to have. Of course we cannot have 66.69 lighting features, we must round that number. Okay, for that part, yeah, that is also very important. If we take a look at this geometry, so all your lighting fixtures are probably somewhere at the ceiling level, but in order to determine this length over here and this length over here, so basically from your chosen lighting fixtures to the space boundary, we need at first to flatten everything. So we will take our lighting fixtures and we will set that the height is at 0, so we can easily then determine the distance between the space boundary and the position of the light fixture. Then at some point we will again increase that height, but in order to calculate everything we need to flatten that. Okay. Find surfaces with max area. Over here basically we have two surface area, I think. Yeah, so we have large surface area for our room. Over here we have some surface for the elevator shaft and so on, and over here I did just create some filter in order to continue with the surface and with the room which have a bigger area basically. Okay, now this is the part that I did describe. So we need to know the longest space edge, and we will declare that the longest spaced edge will be the edge in the x direction. Then we will rotate that vector for 90 degrees and find the longest edge for the opposite direction. We need also to reduce what is available. So when we calculate the total length, we must reduce this part over here and this part over here, because we don't want to have lighting fixtures that will be beyond our room. And basically we will do the same thing for the y. Again, for x and y we will repeat everything, and at some point we will click control if our points does intercept with a space, but I think this is not necessary anymore. At the beginning I did have some different logic. I will create a calculated number of points and then I will check if maybe I have some points which is beyond the space. But in this way, when you subtract this length over here and this length over here, you should not have problems with points going beyond the space. Okay, so when you have all the points in the x direction, then you need to calculate then you will need to calculate how many of those rows you need to have with an increment of 600. That's okay. Now you need to combine all points, so you need to take all the points in the x direction, all the points in the y direction. You need to create those family instances by face. That is why we need to select the face. We need to flip those elements, and we need to rotate those elements to be aligned with the ceiling. And yes, because if we don't do this, when you click on the lighting fixture, it has a dedicated schedule level. Also, when we create lighting fixtures, let's say 30 of lighting fixtures or 10 of them also, then if we don't set the schedule level, they will not have any information for the level. So we will also read at the beginning for our chosen element what is the schedule level, and then we will set that information for all elements which we did create. And that is basically it. Again, this is not like full functional script. Maybe you can just adopt this algorithm, maybe even improve it and use it for your own needs. If you have any questions, just let me know in the comments. Thank you for watching. Bye.